Do teachers know the learning levels of their children in the class? It turns out that this is rocket science, or arguably even more difficult than rocket science. Getting our children to learn well is the biggest challenge that humanity faces today.
Hello, my name is Pranav Kothari. I work at Educational Initiatives. As part of the large-scale education programs, EI looks after how assessments and personalized learning through Mindspark can be taken to communities that need it the most in all parts of India. I'm so excited to have Sridhar Rajagopalan on the show today. Sridhar is a co-founder of Educational Initiatives, is currently the President and Chief Learning Officer of EI. He's currently based in the US, but spends a lot of his times on evenings and mornings helping the India teams do better. I have literally grown under Sridhar over the last 7 years. Everything that I know has been sitting next to his office, sitting next to a phone, talking to him. In this show, I want to share what I have learned over the last 7 years by asking him, what is the role of assessments in improving education reform? How did that lead to a technology-based solution like Mindspark, which helps every child learn at their pace? Sridhar has volunteered a lot of time on helping governments understand how systemic reform can be done by building capacity within the system. Currently, Sridhar is spending a lot of his time on the science of learning as a field, as a multidisciplinary field that would be the tide that rises all boats. In this talk, I want to ask Sridhar how India can do better on PISA, and what advice does he have for educational entrepreneurs? Thank you so much for coming. I really appreciate and look forward to our discussion.
Thank you.
Sridhar, why did you, after a degree from IIT Madras and IIM Ahmedabad and working at IBM, why did you leave that to start a school?
Right from the time after IIM, I was keen that we do something that is meaningful and makes a difference. So in fact, that was the reason I was a big believer that technology was the way to bring about change. So I was very excited about working with IBM, as just seen as one of the leading technology companies at that time. As I spent 2.5 years in IBM, one of the frustrations I felt was that the technology we were working on was, to put it bluntly, not making a difference. I think this was way before. This was a time when the railway reservation system was just beginning to start, but we were selling computers, PCs, to companies, but it was not really making the kind of difference we looked at. So that was something that frustrated me. That was the same time where I had reached out, and some of us, Venkat, who was a colleague, and Mr. Sunil Handa, who had taught us a course at IIM, himself an entrepreneur, had been debating about how education was the route to creating change, and how it can make a difference that lasts across generations. So somehow they were also thinking of the idea of starting a school. So though they wanted to start with the experienced principals running it, but in a long conversation we just decided to take the leap, and in '96 we got together and decided to start Eklavya School. So that was how it started out in the beginning.
And why did you think about starting EI?
So after running Eklavya for about 6 years, one of the things that we did in Eklavya School after the school had started was, we realized pretty quickly that you cannot have a great school without having great teachers. So I remember it started off as a teacher training course. So initially it was a course that people would come for and do for a period of 6 months. We then realized that it was important enough to do full time. So within 2 years of starting the school, we started a full time teacher training college on campus. While running the teacher training campus, we said that this is the normal way of running a teacher training course. Used to be that you do a 9 or a 10 month course in a college, and you get a B.Ed at the end of it. So we kind of changed all these three things. We said a B.Ed is focused on secondary education. We wanted to train teachers for primary schools. We said 1 year is too short, so we did a 2-year course. And most importantly, we said you can't train a teacher by sitting in a classroom in a college. So the schedule was planned in such a way that every alternate day, these teachers would go to a school, and the other day, the alternate day, they would be in the college. So once we were doing that, and our trainees were going to these schools, and in the school every alternate day, every week, every Saturday, they would come back and share their experiences with us. And that is when we realized that a lot of what was going on in our schools, including our top schools, because a lot of these partners were top schools, was not really education. It was you were kind of going through the motions. We kind of started seeing the first signs of rote learning, which were kind of also emphasized by other things we saw, in our schools and other schools. But mostly we realized that what was getting transacted in the classroom was a mechanical version of, let me say, completing the syllabus. And through their discussions, we realized we got I think a pretty good cross section of what was happening in schools. And that's when we said that this problem of rote learning seems to be like, it's not just that the children are kind of focusing more on learning the facts. The entire system of teaching and examination seemed to be geared towards rote learning. So that was when we said that we need to kind of work full time on that issue, and EI was started with that purpose, saying how do we so the vision clearly then and now has been to create a world where children are learning with understanding, and we emphasize children everywhere to say that this has to cover specifically emphasize that this has to cover not just children from the elite schools, but all kinds of schools. So the learning that we had from Eklavya told us that rote learning was the core problem, and that was what we wanted to address in EI.
What is ASSET? What was the rationale behind starting an assessment product? How is it helping schools? And what were some of the initial difficulties in convincing schools to adopt the test?
So that's great. So when we started off EI, and we had said that our goal was to tackle and address rote learning, how were we going to do it? What was the idea? And the idea was ASSET. So what we said was that, logically, if you want to remove rote learning, one idea is to kind of do workshops with schools and show them how not to do rote learning. What we decided was that we wouldn't take that approach. Instead, we would simply show them. We felt that the people who were doing this, the schools, our entire system, their intent was not that children should not learn and they should be learning mechanically. Their intent was children should learn well, but they did not realize that there was this kind of rote learning had kind of become a part of our system, and children were not learning. So because that was the case, we said that we will go to them with questions. We will ask them first whether these questions were valid and whether they felt children should know it and would know it. And then we would actually ask the children those questions after the teachers and parents had said that, yeah, these questions are valid. And then we would show them what the children actually performed. And that basically was ASSET. So the ASSET has questions. They are a little different from the traditional assessment questions in textbooks and schools. So it kind of asks you those things that you assume the child knows, but you probably ask something else. And ASSET results continuously show that children do not, they make mistakes there because they have actually not understood those things that you are assuming. So if I were to take a question an example at random, we may ask something like, which of these could be the length of a ribbon, right? And let's say the answer is something like, let's talk of a skipping rope. Let's say what of these is the length of a skipping rope. So let's say it's about 2 meters is the thing. So we say that, so we would have a solution, an option which would be say 200 centimeters. We may say 50 meters or something like that. Now what happens is children have a notion that anything written in centimeters is very small. They don't have a sense of what 200 centimeters is. So they may say that it's 50 meters, not knowing. So they kind of know that 100 centimeters make a meter. They kind of know it mechanically. It's not something they apply in their thinking, but they kind of mechanically think, okay, centimeter is small, meter is large. And you will see that I don't remember the exact statistics for this question, but you might find that 50% of children, 60% of children choose 50 meters as the option, which everybody, teachers, parents are shocked by. So we used ASSET as a way of kind of creating this thinking that, oh, there is a gap and why are children thinking like this? We followed it up with interviews of children, which we again, made available in the public domain. So the idea was that use questions to create, bring about this kind of thinking and create change in the system. So that was the logic about ASSET. Very quickly, the challenges we faced. So absolutely, schools would tell us that, here was a test that we were asking them to pay for, and we would go to them and explain to them. And they would say, you're asking us to pay for something, but our teachers make questions and it doesn't cost us anything, and we don't pay for any tests. So we explained to them the research that goes behind it. When we finally leave an ASSET paper or a sample set of questions in the early days when we did not even have the paper, and said, why don't you show this to your teacher and ask them for feedback? And invariably the feedback would be that, yes, these questions are really interesting. Our teacher said that they were different. We'll give it a shot. So that was the way that it kind of started off gradually, and then grew a lot to a point where 300 to 400,000 students were taking it regularly year after year, and that was how ASSET started.
Sridhar, can you tell us more about MindSpark, what it is, and how did you come up with that idea?
Yeah. So as we had learning data and assessment data from something like ASSET for a number of years, we noticed that there were very clear patterns in learning. So like I said, we had longitudinal data for a number of years. That means the same child with their responses in grade 4, later in grade 6, and later in grade 8. And whenever we analyzed this, we found that there were very clear patterns. A child who was showing a certain type of misconception in grade 4, there was a pattern. On a similar topic, you could see that this is the child and they have learned something, but this is different from a child who did not have that misconception in grade 4. So we said that if there is a clear pattern that is there, can we use this longitudinal data to actually address that issue and remediate the issue? And that's when we started looking at a system that can actually serve up questions and activities to children based on the learning gaps that they have. And that was MindSpark. So, and remember, this is around 2008-9 when we started this. We already had about 8 or 9 years of assessment data, which was a large amount of data. Every single child who took a test, we had data question-wise with the date, with the age of the child, with the name of the child. So it was great for all this kind of analysis, and we were able to see patterns of how those learnings progressed. So what MindSpark did was it used these patterns. It used the fact that when children are learning decimal comparison, they tend to make one of these 4 kinds of errors. It actually assesses to detect that error and then uses activities to correct that error. And in a way, if I may say, exactly parallel to the medical analogy. Look for certain, that there could be these 10, 20, depending on the domain, number of problems. Look for them through a set of tests. Identify which problems exist. You already have a set of solutions for all the problems, so apply the solutions that are needed for the particular problem that child has. So that's what MindSpark does. It's a pedagogy-based adaptive learning program. It's adaptive because if you have problems A, B, and C, and another person has D, E, and F, you would get different activities and different content. It could just be that you have moved ahead, or it could be that you have different set of misconceptions from the other child. In both cases, MindSpark will adapt, give you exactly the kind of things that suit the problems you have, and at the end of it, you again check whether the child has learned it or not. So that is what MindSpark does. It's a pedagogy-based adaptive learning program that is personalized and uses the child's strengths and weakness to help them learn better. Available originally in math, but currently also in English for the last few years, available in a number of languages, and adding science also now.
Sridhar, for thousands of years, we have survived just fine without technology in education. Do we really need technology? And if yes, in what ways can technology play a role that can enhance what teachers are already doing today?
So see, when we say that for 1,000 years we have lived without technology, what we mean is that maybe for thousands of years we have lived without computers. But that's the beauty of technology, right? From the first day, thousands or millions of years ago, we were using technology, and we never stopped refining and improving the technology we used every fine day. And actually, that's exactly what technology is. It's our ability to create tools that help us solve problems better. And I think that's what computers are, that's what internet technology is, that's what Mindspark is. And just as in our day-to-day life, we use different elements of this technology to make things easier, that's what education technology can do for learning. Technology does have negatives that we have to watch out for. Technology is not a replacement for human effort, human intelligence, human creativity. So it's not that, I sometimes give the analogy that you are standing on the floor and reaching out, trying to touch a spot. Now technology gives you a stool, which lets you reach out much more. But that does not mean that you don't stretch anymore. Yes, if you can now reach the same point you could reach without stretching because you have the stool. But the stool allows you to stretch even further. And human development, learning, growth, meaning is from that stretching. So that's very important, that the role of technology is not to replace or remove human effort, probably not even to really reduce it. It's to kind of stretch us in new ways, to do greater and more meaningful things, and if I may say so, greater things, for the good of all. So just like other technology, education technology has that potential. The students actually learn better, they understand better. If you now kind of question them on those aspects of decimals or photosynthesis or measurement or anything else, they are doing better. And I'm sure there are other topics that we haven't yet figured out or others haven't figured out. So it's a continuous process. But we're using that measure of our children really learning better. I think there is a lot of potential, and there are good examples of how technology has done this better and can continue to do so.
Sridhar, in this world of finite resources, time, manpower, what investment in education would yield the highest return in terms of improving learning outcomes at large scale?
Okay, that's a big and a difficult question. The way we see it is that, and I sometimes like to think of this through the lens of a government. So if you have a government and you have the education or the human resource development department of this government, it could be for a state, it could be for the country as a whole. What could I do as the education minister, so to say, to create the maximum impact? So I think resources is one question, but it's also a question of priorities and prerequisites and so on. And we have come up with a set of ideas and 10 or 11 priorities. These are the things that one could look at. And I think this kind of comes even before we get into the financial allotments, because some of these are the ways you think and the programs that you do. So one of the things, I think one of the core ideas is this whole notion of, which is now well understood, the notion of inputs, outputs and outcomes. I think we've played a role in kind of emphasizing, and thanks to the fact that we are measuring outcomes, to say that outcomes can be measured. But I think that's the first fundamental shift. That, do you invest in inputs, or are you kind of in a sense investing in outcomes? So when you invest in inputs, you're kind of building a school and you're ensuring that children can go to the school and teachers are there in the school. And from an input perspective, the job is done. But when you are focusing on outcomes, these were a part of a process, and you may do this process in multiple ways. For example, you may provide only a few consolidated schools, but you will probably provide transportation to come to those schools. Why? Because it turns out that from an outcome perspective, small fragmented schools lead to either fewer teachers, you don't get the critical mass, you're not able to manage that school very well. So from an outcome perspective, you tend to say that, no, let's do it the other way. So that's just one example. So I said this to say that in terms of thinking, we need to think in terms of outcomes. But once we agree on that, one of our first recommendations we say is, make the learning visible. So are children learning? Are they learning great. I mean, I remember when we started EI, one of the questions we asked was that how is the quality of learning in Delhi schools compared to those in Bangalore schools? And we said we have no idea. And fortunately, due to some of the studies that we have done and others have done subsequently, we do have an idea today. So, the first recommendation that we have is that make the learning visible, so there is awareness of, first of all, is it good, is it not good, is it a big concern in certain districts, is it a big concern in certain topics. So that and it's possible to do this. Right. Where does learning in this state or our country stand compared to some other country or some other state? So that's one example of something that we strongly recommend. The second thing that we would recommend to a state is what I would call building institutional and systemic capacity. So the role of institutions, so you have an SCRT in a state, that's the State Council for Educational Research and Training. You also have a national body, the National Council of Educational Research and Training. You have the boards, the CBSE is a board, but Gujarat would have a higher secondary board. The role of the boards is to create the board exam papers. You have the diets. So a diet is at the district level. It's an institute where they do teacher training, they do both pre and post training, but they're supposed to do other stuff also like research in education. So these are institutions, and if these institutions are strong, if they have good academic capacity, this means that they are able to serve the teachers and the larger system better. And today, often there is a capacity gap. If your boards have very strong capacity, they create question papers that are aligned with what we need today. If e-assessments, technology-based assessments is a trend and an important trend for the future, a board is kind of evaluating that option maybe for years before they actually announce it.
Right.
So this is a kind of a way of describing institutional capacity. Systemic capacity is a basic ability. For example, do we know how to help every child in India to read? If we had a group of 100 children from a backward area, and we know that one of the challenges, thanks to ASAR and many other reports, one of the challenges is that these children don't read well when they reach grade 4 or 5 or even later. But what is the approach? Suppose we had 1,000 children from a set of schools in some district. What is the way that we would get them to read? This knowledge is what I call systemic capacity. This knowledge eventually has to reside in the institution and the people in the institution. But somewhere this knowledge has to be there. A lot of the time, this knowledge does not exist. So we have to create this knowledge. There is the culture of research exists in many societies in some Western countries and other countries, but they are probably not going to be bothered to research how to get children in our rural areas to read. So we have to create that. I call that systemic capacity. That is done by a few people in these institutions, and then it kind of resides in those institutions. So when these things exist, your assessment papers are good, you are training teachers well, and so on. So that's another example of what we do.
But some of these basic things like children able to read, especially in their mother tongue language, isn't that already known? I mean, that doesn't seem like rocket science to me, that children can't multiply and we don't have the knowledge to be able to teach that to our children.
Do teachers know the learning levels of their children in the class? It turns out that this is rocket science, or arguably even more difficult than rocket science. Getting our children to learn well is the biggest challenge that humanity faces today. And we may think that the problem in India is definitely far more severe, because definitely we have far more children who are not able to read than, say, other countries. But if you were a more advanced country, you are also trying to figure out, how do I develop a spirit of collaboration in my children? How do they use technology effectively? So when I say that as humanity as a whole, the biggest challenge that faces us today is effective education. And really, if you read the papers, or I live in the US now, but even in countries that others feel are doing well, so if you look at Singapore or something, you'll find that this desire that our education system can do more and we need to do much better is there, and I think for very good reasons. So, but if you come back to the example we spoke about, something that looks simple, like getting children to read, the fact is that we just don't don't know the answer. In fact, if you look at the amount of money and effort that is being invested in this, it seems intuitive that this is an easy thing to do, but we need to overcome that intuition and recognize that it is actually a hard thing to do. I would start off with the thing that's saying we don't know how to do it, rather than say that we know it is just a delivery issue that we are not getting there. We really don't know how to do it. We need to get it to a level where it is like much more easily available.
What is the science of learning that you refer to?
So the science of learning is at a very simple way, simply a systematic way, a scientific way to approach and look at learning. So how do you treat learning? What does a school do? The default way is to say that, okay, there's a textbook, there's a teacher. The teacher obviously knows what's in the textbook. The teacher goes to the class, kind of transmits or transacts this curriculum, and the children learn. So I would say this is the default, probably a simplistic way. A science of learning says that the process of learning is a scientific one. We need to study it systematically. There are insights, there are patterns, and we can do this well. One analogy that people sometimes use, and I have found very interesting to study, is that the science of medicine developed in a similar way. Sometimes people think that, like the physical sciences, medicine also must have developed over the last thousands of years of human civilization. But it's interesting that everything that we call the science of medicine today, especially the allopathic form where you diagnose diseases, you have tests, and then you treat them, everything was literally developed in the last 80 or 90 years. And if you go back 80 or 90 years, you'll find that not a single treatment that we use, even the treatment for a common cold, whether it's the diagnosis or the treatment, existed 80 or 90 years back. And there are books on this, but it's very interesting to see how and why the science of medicine developed. And it developed from a science where there was literally nothing. In fact, even the few methods it used, like using mercury and arsenic as medicines, are completely like no-nos today.
Of course.
From that point to where today, not only are there diagnoses for 4,000 to 5,000 kind of symptoms and diseases, these have been so beautifully standardized that if you are going to be tested for hepatitis A, it would be the same test whether you're in India or in Africa or in London. So that is the science of learning. But if a child had to be, was not able to say compare two decimals properly, if you see the toolkit the teacher has, it's virtually nothing. I mean, what would a teacher do if a child was struggling with decimal comparisons? They would probably say, do more sums. If 4 children were struggling, they'd probably tell all the 4 do more sums and probably observe them or supervise them doing it. It's like 5 people go to a doctor and were simply told, oh, you have a fever, so take this medicine. We would it's unthinkable. I would diagnose them and probably treat them differently.
Right.
So we believe, and all our data, with all our work with the data and the work with Asset, and once we started Mindspark, the data exploded. We now have data literally every 40 seconds from every child as he answers a question. All this data shows that this does exist. That in learning decimals, there are as many nuances and as many specific skills that can be measured and separately treated. And that is the science of learning. And this needs to be available to teachers, available to people who are developing solutions. And that is what can help children learn better. So that's what we call science of learning.
Sridhar, if such a science of learning would exist, how would it manifest itself and how would it benefit the students?
Yeah, again, I'm going to give you a simple example from medicine. The important thing is that in medicine, we kind of just take all this for granted, and in education, we take the opposite or the absence of it as granted. So in a way, it also makes the analogy easier to understand. So, if you are unwell, let's say you're traveling somewhere and you fall sick, you can go to any doctor, explain your symptoms to them. The doctor might ask you to take a test. You can ask around, maybe check at 2 different labs, go to a particular lab, get your test done. But since you are traveling, you're not able to go back to that doctor, so maybe you go to another doctor. You show them the test results. The doctor sees the test results. They are able to completely understand what is to be done. You can prescribe a medication, which you take to any pharmacist. And then the pharmacist may also actually tell you that there are these medications from 2 or 3 manufacturers which are equal. So what we see here is an ecosystem of a number of doctors, a number of labs, a number of pharmacists, a number of medicine manufacturers, all of which are able to kind of coexist and build on something so that the end user, which is the customer or the patient, is able to get help, as they require. Now, why is this possible? Because there was this common language or common taxonomy that was shared across this entire ecosystem. In education, this is not the case today. So I do go to a school and I can learn math in the school, I take a test, but then when I get my test result, my tuition teacher cannot interpret this. My parents cannot really understand from that test and the score easily that these are the areas that I need help on. If I use an EdTech software, I can't plug in the teacher results directly and the software help me where the teacher recommended, and then the teacher see where the software helped. So if you can imagine those two ecosystems, one of them is like highly connected. If I move from one city to another, one state to another, one country to another, I am now negotiating a completely different system, which is, like I said, pretty different from how it worked in medicine. So one of the things science of learning would do would to really make this much more seamless in that way. And one of the side effects of that is to allow a lot more participants to come in and contribute in their own way.
There's a lot of discussion and attention focused on children who are not at grade level, children who are really struggling. But there is a set of students who are very bright, who are academically gifted. Is there any attention being spent on them? If there should be, what should it be? And how can these gifted students be nurtured to become nation builders?
When we do assessment, we actually get the whole spectrum of results. We do work with the group as a whole, and while we get children performing at the average level, we get children who are weak and who need support, and we talk a lot about that. And there is the whole MindSpark approach, which of course also focuses on the stronger children, but a lot of the focus obviously is on diagnosing learning gaps and addressing them. But what we have found is that there is a huge payback to society. Sometimes what happens with gifted children is that people think that these kids are good, they take care of themselves, or I don't have much money, I have to use it on the children who need help. Why should I focus on the children who are doing well?
Right.
But the reason that we should focus on the children who are gifted, so there are different ways of defining gifted. One of the widely established ones, which is what EI also uses, is that we take children who are in the top 5 percentile of their topics in different subjects. So it could be an English, math, or science. But then we give them a higher level test, which means a grade 6 child would get a grade 8 test, a grade 7 child would get a grade 9 test, a test which is 2 levels higher, which means that when you take that test, there might be 15% where you do not even understand the terminology because you haven't learned that. And in spite of that, these children are so bright that they perform as a group higher than the average of that higher class. But then the very top performers of those children are who we call the gifted children, and we do a special program for them. So this test is called the Asset Talent Search, which is the 2-class higher level test. But then we have an Asset Summer program. We also have partnerships with the universities in the US, because the US has a culture of doing such kind of gifted programs. So the Asset Summer program is a 3-week program that is done in the summer. We are now having additional programs. The Asset Summer program is residential, but we are also introducing non-residential programs in other locations and other durations. But essentially the focus is to not just identify giftedness, but to give an opportunity to these gifted children to do a substantial amount of work which is challenging. it's not grade level but actually a college level course in partnership or in collaboration with other peers who are similarly gifted. So they also get challenged more because in their original class they are like much brighter, but here they are with a group of peers who are all at that level. But they also enjoy that company because now their idiosyncrasy or their passion for their subject is not something that is seen as different, but each one of them has such a passion or an idiosyncrasy. So we find that all of these things work, and we also inculcate in those programs the notion that this giftedness, this talent that they have is something which is kind of inborn in them, or we call it God's gift, and they should use this for the concept that use this for greater good. But research has shown that systematic identification of talent and focusing on them and developing them in this form does bring significant returns for society as a whole. It's not just for the individuals who do this.
Shridhar, we've heard about PISA, and India didn't perform too well on the last round. What can India do to improve its standing on PISA?
Yeah, so just for people's background, PISA stands for Program for International Student Assessment. It's conducted by the OECD countries, and between 80 and 100 countries participate each time. It's done once in 3 years. Looks for regular things like reading, science, math, and so on. And basically, it tries to measure students' ability to apply what they have learned in school. It's meant for 15-year-olds, so that's typically grades 9 or 10, sometimes grade 11 children. And they sample a few students from participating countries or geographies. Now, I think tests like PISA are really good when we said that we should make the learning visible, or we talked about ASSET, and ASSET itself is a test that tries to do something similar. It checks for what children are understanding. And so it's very important. It's also, of course, great feedback because it tells us where we stand. And some countries, I believe South Korea is one, but some countries have really used approaches like PISA effectively to improve their education system. Because again, like any other assessment, if designed well, it gives you feedback on what you're doing well and what you need to do better. And do better is whether it's teacher training or other support. So PISA can be a great way to improve our system. So the challenge in India is what we talked about, which is rote learning, which is that children are focused on writing an exam with the type of questions. So it's like, don't think too much about this, don't focus on understanding, but learn the definition, learn what's in the textbook, and put that down and you will do well. So if that is the approach and the entire system is working towards that, we are unlikely to perform very well in PISA. The good thing about our system is that teachers are serious, students are serious, the desire, the willingness to work hard, the desire to focus, the entire ecosystem supports it, parents value this, which, believe me, is a big thing. It's not something you can say for a lot of societies and countries. But our goalpost is wrong. We are kind of training our children to do well in our board exams, which is not going to either, in my opinion, serve them well in the years in the future, or to do well in tests like PISA. So while a short-term focus for doing well on PISA would be to give children exposure to PISA kind of questions, train teachers on those dimensions, and that can be done in a certain scale, the real solution is to reform our board exam system. And while there are challenges, it's a surprisingly easy solution. So, two solutions that I think I would put very high on the list of things that India should do, and I think it's easy for a country like India because I do believe that we have a strong state system. If we say we want to implement something, we actually can do it well. Of course, a large country full of challenges, but one of them is just changing our board exam to something which is much more like the ASSET test that we have, or a test like PISA, which basically means I'm trying to check what you have really understood and not check what you are recalling. In fact, there is a national curriculum framework document which kind of talks about examination reform. Often people interpret examination reform as whether to have multiple choice questions, or to have 2 papers, or to have a higher level paper, or invigilation. And all those things are important, and we have improved on all those dimensions. But we are really talking about the quality of questions, the type of questions in the paper, because that determines what is taught in the classes. And if we can correct that and improve that, we will, doing better in tests like PISA would be, child's play literally. So that is the key thing, and it's a little difficult to manage, because when you change a particular test, students who are taking that test that particular year or even 3 years later have to adjust to that. But there is no option, and we have made changes like this in the past. So that's one thing that we can do, we should do, and I put board exam reform very high on the list. A second thing which is kind of not connected is this whole issue of children at the early grades, grades 3 and 4, grades 2, 3 and 4, learning to read, foundational learning mathematical operations and being able to do them fluently. So again, if we were to take it up as a national priority, with a government buy-in and a government thrust, and we simply were to measure our children reading, what percentage of children in my state are reading, what percentage of children in my city are reading. So board exam reform and ensuring every child reads well by grade 2 or 3, every child does arithmetic operations well by grade 4 and 5. Frankly, I think these two together will take care of 80% of our challenges, because the rest of it, the ecosystem will come in and make up for it.
There are many of us who are very deeply passionate about improving education in India. For a potential entrepreneur in education, what would your advice be?
Well, first of all, I would congratulate anyone who decides to work in the field of education. Andrew NG, it says that there are a number of interesting problems and a number of important problems. And he says, I wish for my students that they pick the important problems. Education, I would say, is an important problem. It's also an interesting problem, trust me. So I think that's the first thing. The second thing is that which are the dimensions, which are the domains which are extremely important and people spend a lot of money on them and they are like high priority for them. And in those domains, which are the ones where there is growth and where you don't have a leading or a set of leading dominant players. So if you just think about it, you would have spaces like retail, which are growing, but you would definitely have leading players. So it's not like the opportunity is not as much, you have strong incumbent players. But education is huge, it's super important. It's, if not number one, it's number 2 or number 3. In India, it's number 1 on parents' priority. In other countries, it may be in the top 3 or 4, but it's like extremely important. No large player, meaning that there's really opportunity for disruption. So it's also a field which, as we all know, is at the hub of innovation. It's not one of those fields which is like, okay, no space for AI, no space for machine learning, no space for new research. We talked about science of learning. So it's really fertile ground, and there are so many opportunities that I'm not even going to try to list them. But I think that we should pick up, any entrepreneur should pick up something which is a real problem. It could be related to teachers, it could be related to learning, it could be related to supporting school principals, it could be with government. But I think that it's only with all of us coming together, particularly entrepreneurs and private players, along with the government and existing schools and teachers, that we can bring about change that we all hope to see in education. But I'm very confident that this will happen in the coming years and maybe a decade or so.
Thank you, Sridhar, for sharing so many interesting and important stories from your 25-year experience in the education sector. I really appreciate the time that you came and look forward to seeing you again soon. Thank you.
Thanks for having me.
Thank you, Sridhar.